Dear students, in this video, we are going to see complex powers and inverse trigonometric functions of the complex number. Okay, we'll see the first definition. If alpha is a complex constant and z not equal to 0, then we define z to the power alpha by z to the power alpha is equal to e to the power alpha log z. Okay. Now, find all the values of the following. Okay. What is the first question? Minus 2 to the power I. See, by the definition, I can write minus 2 to the power I is equal to e to the power I log of this value, minus 2. That is here. Okay. So, by the definition, I can write minus 2 to the power I is equal to this. Okay. Now, here, we are going to find this value. What? That is log of minus 2 is what? Okay. How to find this value? See, I am going to find this log of minus 2 here separately. Before that, I want to tell you one thing. Already we have seen in the last week video, whenever you find the logarithmic value of any complex number, we had to apply the natural logarithm, that is ln. When you calculate that value in the calculator, see this value in the calculator, you have to see the ln value of this number. Okay, so that I am giving in the note. All logarithms are taken to the base e, that is ln, that is represented as ln in the calculator. Okay. So now we are going to find log of minus 2. What is this? Again, by the definition of logarithmic value of this complex number, I am writing log of absolute value of this number minus 2 plus I theta plus I 2k pi. What is theta? Theta is nothing but argument. Okay. So what is the theta value for this complex number? For this complex number, what is theta value? That is pi. Okay. Now, what is the absolute value of this minus 2? That is 2. So that I write log 2 plus I pi plus I 2k pi. Okay. Now, what is log 2? You have to take the calculator and you have to find ln value of 2. That is 0.693 plus I pi plus I 2k pi. What is this? This is the value of log minus 2. Okay. Now, we substitute log minus 2 here. Okay. So, e to the power I substitute log minus 2. That is e to the power I multiply this value. Okay. 0.693 plus I pi plus I 2k pi. Now, what I do? I multiply I with each and every term here. Okay. So, e to the power I 0.693. Okay. Now, here I and I squared minus 1. So, that e to the power minus 1 pi. So, that I am writing here this. Okay. For the third term here, you see I and I you multiply. That is I squared minus 1. So, e to the power minus 2k pi. So, that is here. Okay. So, now what is this? We have to find all the values of the following. So, now minus 2 to the power I is nothing but e to the power I 0.693 multiply e to the power minus I multiply e to the minus 2k pi. Now, here what is k? K is any integer, which means k is nothing but 0, plus or minus 1 or plus or minus 2, etc. Okay, suppose you replace k here by any value, then you will get different values of this minus 2 to the power I. Okay, that's why here we conclude that minus 2 to the power I has infinitely many different values. Okay, so as after in the question, we can find the values. We can find many values of this question. Okay, that's it. Now we'll see the second question. That is 1 plus I to the power 1 minus I. Now, by the definition, with the above definition, we can write e to the power 1 minus I. This value multiply log 1 plus I. Okay. Now, what is log 1 plus I? Again, you apply the definition which we have discussed in the last week video, that is log 1 plus I is equal to log absolute value of 1 plus I theta. This is argument of this complex number plus I 2k pi. What is this complex number? That is 1 plus I. This complex number lies in the first quadrant. Now, you can find the argument. Okay, that is pi over 4. Okay. Now, what is the absolute value of this? This you know that square root of this 1 squared plus the coefficient of I is 1. So, 1 squared. That is square root of 2. Okay. Now, log of root 2 is nothing but here the degree of this 2 is 1 over 2. So, you can write by the power rule. of logarithm, you can write 1 over 2 log 2. Okay. Now what does log 2 again? See, use calculator. When you find the value of this, you have to find ln2. Oh, find ln2, then you divide by 2 so that the value is 0.3465. Okay, plus I, this you know that already. What is theta? That is the argument, that is pi over 4 plus I to k pi. So this is nothing but log value of 1 plus a. Okay, okay, k is any integer. Okay, now this is the value of log 1 plus I. So now what we do, take this here, substitute. So now e to the power 1 minus I multiply log 1 plus I. So what we do here, you see, before that we multiply 1 with this expression. So log 1 plus I minus here minus I means multiply log 1 plus I, which means minus I log this. Okay. So now, so that I can write e to the power log 1 plus I minus I log 1 plus I. Okay. So now for log 1 plus I, we have calculated this value. So that now I substitute here. Okay. So before that, you see here already I have told you that whenever you write log or capital Log, that represents the natural logarithm. Okay. So now see e and see e to the power log 1 plus I is nothing but this and this will be cancelled, so that you will get 1 plus I. For this term you will get 1 plus I. Okay. Now because here the base is e to the power here ln, which is here natural logarithm, so that here e to the power natural logarithm of 1 plus I, you will get 1 plus I1. Okay. Now here in the second term you can substitute this value. So e to the power minus I, this value is nothing but here. Okay. Now we substitute. So e to the power minus I multiply this value. Okay. So that now e to the power, you multiply this minus I inside. So that e to the power minus 0.3465 I multiply this minus I and this I, that is minus I square, that is plus 1. So that here I write pi over 4. Okay. Then here minus I into I, that is plus I square. Sorry, minus I squared, that is plus 1. Again 2k pi. Okay. So that for minus I multiply with I, you will get plus 1. So that here no I, here no I. Okay. So now this is the value of the given expression 1 plus I to the power 1 minus I. So now for all values of k, you will get different values of this term. Okay. So that here we are writing 1 plus I all to the power 1 minus I has infinitely many different values. That's it. Now here we will see the inverse trigonometric function values of the complex number. You see, for any complex number z, we define sine inverse of z as minus I logarithm of iz plus 1 minus z squared all to the power 1 over 2. Cosine inverse of z is nothing but minus I logarithm of z plus z squared minus 1 power 1 over 2. Tan inverse of z is equal to I over 2 logarithm of I plus z over I minus z, since z not equal to plus or minus I. Okay, this is the definition for the inverse trigonometric functions of any complex number. Okay, now find all the values of the following. Now first one, sine inverse of I. Here we have to find the value of means sine inverse of the complex number I. Okay, how we will find? You see, now this is the rule for the sine inverse of the complex number z. So now the complex number is I. So that here you substitute for z I. Okay. So minus I logarithm of the I, here put I for z, and then 1 minus z squared. So here put I for z. So z squared is I squared power 1 over 2. Okay. Then here what is I squared? That is minus 1. So minus into minus plus. So 1 plus 1 2. So that 2 to the power 1 over 2. Now here I into I squared, that is minus 1. That's it here. So minus I logarithm of minus 1 plus 2 to the power 1 over 2. Okay. Now here what we get after simplification of this, you are getting log of 0.414. Okay. Now we have to find the value of this. See here, this is ln of 0.414. Okay. So how to find this? Already we know that. So ln of this value means logarithm of this value is nothing but logarithm of absolute value of this complex number plus I theta plus I to k pi. What is theta? Theta is nothing but the argument. So now see here, this is having the only real part and imaginary part is 0. This real part is positive, so that your theta is 0. So that you write log of this value from the calculator. You have to find here ln value of this in the calculator. Ln of this in the calculator, that is 0.882 plus this is 0. So plus I to k pi. Now what is k? K is any integer. Okay. Now you substitute this value here. Okay. That's it. So minus I multiply this is nothing but from here I can substitute. I can replace this value by this one. Okay. So minus I multiply minus 0.882 plus I to k pi. Okay. So now here see this is typing error. So now final answer is 0.882i, because if you multiply minus I with this minus, so that you will get plus I. So that here. Then here minus I multiply with this I, that is minus I square, that is plus 1. So that here plus 2k pi. Okay. Now we'll see the second question. Cosine inverse of 2i. Okay. Now this is the rule for the cosine inverse of the complex number z. Now z is 2i. So now you substitute z is equal to 2i here. So now you will get is equal to minus I logarithm of 2i plus square root of minus 5. Okay, if you substitute here. Okay. So now after simplify these all the steps, what you will get? Minus I log 4.24i. Okay. So now how to find the value of this one? We know that. That is logarithm of 4.24i is nothing but log, this is absolute value of this complex number, plus I theta is the argument plus I to k pi. Now here how to find the absolute value? That you know that. So that now log of 4.24 plus I, this theta is 5 over 2. Okay. Now here you find in the calculator ln value of this is nothing but 1.445 plus the remaining term. So now what is k? K is any integer. Okay. So now what you do for this, you substitute this value here. That's what we have done here. Is equal to minus I multiply, see 1.445 plus I pi over 2 plus I 2k pi. Okay. So now after that you multiply this minus I inside, so that you will get this. This is the final answer of cosine inverse of 2i. Okay. Now we will see the third question. Tan inverse of 3i. Okay. Here this is the rule for the tan inverse of the complex number z. Now what is z? Z equal to 3i. Okay. So now you put here z 3i, here z 3i, so that you will get this. So now after the simplification of this, see here you substitute here z 3i, so that you will get I over 2 log of, here after the cancellation you will get this. Now you have to find the value of log minus 2. We know that here this is the absolute value, this is the argument. Okay. So that you find this value in the calculator ln of 2. Okay. That is 0.693 plus I pi plus I to k pi. Okay. Now you substitute this value here for log minus 2. That is I over 2 multiply 0.693 plus I pi plus I to k pi. Okay. So now what you will do? Multiply this I over 2 here inside this bracket, so that here 0.3465 I for the first. For the second one, I into I squared minus, so that minus 5 over 2. Similarly here 2 cancel, so I into I squared minus, so minus k pi. Okay. K is any positive integer. Okay. Now this is the value of tan inverse of 3i. If you change the value of k, you will get the different values of this tan inverse of 3i. Okay. That's it. Thank you.